Today we're covering section 2.3, which is on drawing conclusions. The reason we need this section, and a lot of times in geometry we are given exactly what we need to prove, but in real math, with mathematicians have to actually prove something, they're not told what exactly they need to prove. So the idea in drawing conclusions section is that we have to come up with what could we possibly prove based on the information that we have. So progress is linked to drawing these conclusions, that ideas are discovered and we attempt different processes that we hadn't attempted before. And it's very important that we understand that only certain conclusions can be drawn. So if I give you something with right angles, you're not going to say that an angle is obtuse necessarily, unless you have enough information in the given. It's an important step in learning geometry because now you're going to start looking at that given information and start thinking about what's ahead. You're going to think 2-3 steps ahead and look towards that given information, be able to sequence it out before you even start the proof. That's going to help you develop your own proofs. The process is simply this: you memorize theorems and definitions. We've been doing that already. We've talked about what the definitions are, what the theorems are, and exactly when to use them. Look for keywords. So there's some keyword or symbol in the problem, whether it be a perpendicular symbol or it says right angles or something to that effect. That's going to kind of give it away and lead you down the direction of what we want to actually prove. Then decide which theorems or definitions are going to be useful. Are there any keywords that match up with those keywords that we started with? And then draw the appropriate conclusion. It's got to fit what you know, and it's got to fit what you can prove. So as a quick example here, we know that given we have angle A is a right angle and angle B is a right angle. So if we start thinking through the thought process here, again, memorizing the theorems and definitions, I can't show you that because you have been doing that all along, right? So step 2 is look for any keywords or symbols. Right angle seems like an important piece of information. So we start thinking about, what does right angle have to do with anything? Well, we talked about perpendicular lines in a couple sections ago. Maybe we can show that something's perpendicular. We've already talked about right angles being 90 degrees. Maybe we can show that an angle is 90 degrees. And along those lines, maybe we can show that we have complementary angles. None of those seem to fit because they only mention one right angle. And in fact, in the given information, I've actually got two right angles, angle A and angle B. So my most logical conclusion would be to show that angle A is congruent to angle B. Again, our keyword is right angle, and all of the different relevant theorems and definitions we have dealing with perpendicular, complementary, definition of right angles, and our first theorem that all right angles are congruent seem to fit. But this theorem with all right angles are congruent is the best because it takes care of all of our given information. So angle A is congruent to angle B is our conclusion. Example 2, where you have AB, line AB, perpendicular to line BC. So right there, there's our key piece of information, perpendicular. So we start thinking about what perpendicular means. It means one of two things. Either we have a right angle or a 90-degree angle. And we're going to choose. We've already talked about right angles, so I'm just going to kind of continue that path. And if we know that AB and BC are perpendicular, then our conclusion is that angle B, oops, and it would help if I could write today. Let's try that again. Alright, angle B is a right, it's not much better, there we go, a right angle. That's our conclusion. Similarly, like I said, we could say that angle B is a 90-degree angle. It's going to give us the same information. So in the next example, number 3, looking again at our important information, complementary. So just from the notes that we just took, complementary angle, either one of two things happens, 90 degrees or right angle. And in this case, I'm going to go with the 90 degree because we haven't mentioned it yet. So I'm going to say that angle HED, or I could say the measure of angle HED. There's a better H. And that's going to equal 90 degrees. And we know that's true because complementary angles add up to 90 degrees. The two smaller pieces, HEF plus DEF, equals HED. Example 4, we have angle WXZ is congruent to angle YXZ. So why don't I mark this off so we can see exactly what that tells me. Again, no real key terms in this, but looking at the diagram, when I mark that off, that tells me that something has happened to this larger angle, angle WXY. So if I have two pieces of an angle that are the same, what that means is that the bigger angle has been bisected, cut into two equal parts. So my conclusion here is going to be that XZ, and we're going to call that a ray. You could technically call it a segment, but when you've got bisectors and it bisects an angle, it's technically supposed to be a ray because it's going to keep on going. So XZ bisects angle WXY. That's really the only valid conclusion we can draw based on the given information. So looking at number 5, we have that ray QS and ray QT trisect angle PQR. So trisect is our key piece of information here. And if we think back to chapter 1, the definition of trisect means it's going to break something into three equal parts. So it's going to take our angle PQR and it's going to break it into 1, 2, 3 congruent parts. So my conclusion, and really there's not much else I can say, the most logical conclusion would be that angle PQS is congruent to angle SQT, which is congruent to angle PQT. If you want, a reasonable conclusion would be to pick two of the angles and say that they're congruent. But because it's a little bit more powerful to say all three, let's use all three. For example 6, where you have a midpoint, so we know if E is the midpoint of this segment AC, so here's our segment AC. Midpoint is the key piece of information. And again, thinking back to section 1.5, where we talked about bisectors and trisectors, a midpoint is a segment bisector. So what that means is it's going to cut segment AC into two equal pieces, segment AE and segment CE. So that seems like a logical conclusion that AE is congruent to CE. Midpoint cuts a segment in half. Those are the two halves. So example 7, we have A and R trisect segment CD. Again, that key word there, trisect, three equal parts. So we've got 1, 2, 3 congruent parts right there. So my conclusion seems to be that I can say each of those three parts are equal. So I'm going to say that CA is congruent to AR. Oops, there we go. Which is congruent to RD. And like we did with that angle one a minute ago, if you want to pick two of the three, that's a valid conclusion as well. But because we have the information to say that all three are the same, why not say that all three are the same? Alright, here's one of my favorite ones. This says that the given information is the diagram, which doesn't seem like it's very helpful. There's not a lot of keywords in there, but we've talked about this in class that if you have a diagram and that's your only given information, that there's something that you need to do to continue the proof. And we had said that we were going to assume that we had a straight angle. So a valid conclusion would be that angle PQR is a straight angle. But there's a little bit more going on, and it has to do with that ray right there. What's happening is this ray QS is going to divide angle PQR into two pieces, not necessarily equal, and based on appearances I definitely don't think they're equal, but it divides it into two smaller pieces. If I take the two smaller pieces, we'll just call them 1 and 2, and put them together, then they're going to give me 180 degrees or a straight angle. So I think we talked about this in 2 sections ago, that if we have two angles that add up to 180, that we had a special word for that. We called it supplementary. So my conclusion would be this, that angle PQS is supplementary to angle RQS. Now the reason this is a better conclusion than just saying that PQR is a straight angle is not only do we have to show that PQS or PQR is a straight angle to get there, but now we can say a little bit more. So more is better in this case. We can actually say that these two angles are supplementary, and in order to do that we had to assume the straight angles to begin with. And you may or may not see an example just like that again in the future. And we will stop the notes there.